Let's start with something interesting. Number 9. The first climate change calculation, 1896. In 1896, a scientist quietly calculated the future. There were no highways packed with cars, no commercial airplanes slicing through the sky, no global climate panels debating emissions. Just a man, a desk, and mathematics. Svante Arrhenius, a Swedish chemist, calculated how much Earth's temperature would rise if carbon dioxide levels increased. Using basic thermodynamics and radiation physics, he estimated that doubling atmospheric CO2 could significantly warm the planet. This was not speculation. It was physics. He understood something unsettling. Carbon dioxide traps heat. It absorbs infrared radiation, escaping from Earth's surface, and sends part of it back down. The more CO2 in the air, the more heat stays trapped. At the time, this didn't feel dangerous. Industrialization was still growing. Coal use was rising, but the scale seemed small. Some scientists even believed a warmer planet might benefit colder regions. So the calculation wasn't treated as a warning. It became a curiosity. The paper remained in scientific archives while factories expanded, engines multiplied, and fossil fuel consumption accelerated throughout the 20th century. Decades later, improved measurements confirmed what Arrhenius had outlined with pencil and paper. Rising CO2 levels correlated with rising global temperatures. The foundation of modern climate science had been written more than a century earlier. The discovery wasn't suppressed with secrecy, it was sidelined by timing. The world wasn't ready to see it as urgent. Sometimes a discovery isn't buried in darkness. It's buried in complacency, and by the time it's rediscovered, the equations are no longer theoretical, they're measurable. Number 8. The expanding universe discovery. In the 1920s, the universe was supposed to be still, static, eternal, unmoving. Even Albert Einstein believed it. Then a quiet astronomer named Edwin Hubble looked deeper into the sky than anyone before him. Using powerful telescopes, he measured the light from distant galaxies and noticed something strange. The farther away a galaxy was, the more its light shifted toward red. Redshift. That shift meant those galaxies weren't just sitting there, they were moving away. And the farther they were, the faster they were receding. The universe wasn't static. It was expanding. This discovery shattered the dominant belief of the time. Even Einstein had introduced a cosmological constant into his equations to force the universe to remain stable. When confronted with evidence of expansion, he reportedly called that addition his greatest blunder. But the idea didn't immediately transform public understanding. It took years for the scientific community to fully absorb what expansion meant. If everything is moving away from everything else, then rewind the motion. Go backward in time. The universe must have once been smaller, denser, hotter. The foundation of what we now call the Big Bang Theory began with those redshift measurements. The unsettling part? Humanity believed for centuries that the cosmos was fixed and permanent. It took one careful measurement of distant light to reveal that space itself is stretching. The sky isn't standing still. It's unfolding. And it has been since the beginning. Number 7. Deep sea life without sunlight. For most of human history, life without sunlight was considered impossible. Sunlight was the foundation. Plants needed it. Animals depended on plants. The entire food chain traced back to the sun. That was the rule. Then, in 1977, scientists exploring the deep Pacific Ocean found something that rewrote biology. Nearly 2 miles below the surface, where sunlight never reaches, they discovered entire ecosystems thriving around hydrothermal vents. Giant tube worms, blind shrimp, strange crabs. Dense clusters of life in complete darkness. No photosynthesis, no sunlight. Instead of drawing energy from the sun, these organisms relied on chemosynthesis. Then bacteria near the vents converted chemicals like hydrogen sulfide, toxic to most life, into usable energy. Those bacteria became the base of a food chain independent of sunlight. Heat and chemistry replaced light. The discovery shocked scientists. It proved that life didn't require the sun in the way we assumed. It only required energy. and energy could come from Earth itself. Before this, the deep ocean floor was thought to be mostly barren, cold, sparse, lifeless except for drifting debris from above. Instead, it contained biological islands powered by the planet's internal heat. The implications went far beyond Earth's oceans. If life can exist without sunlight here, it might exist beneath the icy crust of moons like Europa or Enceladus, where oceans may hide below frozen surfaces. The discovery wasn't buried out of secrecy, and it was buried under assumption. We believed light was mandatory. The deep sea proved otherwise. Life doesn't just follow the sun. Sometimes it follows the heat rising from the dark. Number 6. The discovery of prions. In the 1980s, biology faced something it wasn't prepared to explain. An infectious agent that wasn't alive. No DNA, no RNA, no cells, no metabolism, just protein. For decades, scientists believed all infectious diseases were caused by bacteria, viruses, fungi, or parasites, organisms with genetic material. That was the rule. Then researchers studying mysterious brain diseases like Creutzfeldt-Jakob disease and scrapie in sheep found something impossible. The infectious agent contained no genetic code. Sir Stanley Prusiner proposed a radical idea. Certain proteins could misfold into abnormal shapes and force other normal proteins to misfold as well, like a molecular domino effect. These warped proteins, later called prions, accumulated in the brain, destroying tissue and leaving behind sponge-like holes. No replication in the traditional sense, no living organism invading the body, just shape infecting shape. The scientific community resisted the idea at first. It violated a central rule of biology, that information flows through nucleic acids, DNA and RNA. Proteins weren't supposed to transmit disease on their own, but the evidence kept building. Mad cow disease, fatal familial insomnia, Kuru, all linked to misfolded proteins spreading damage without genetic material. Eventually, the theory was confirmed. Prusiner received a Nobel Prize. The unsettling part? Life wasn't required to cause infection. A molecule's structure alone was enough. Prions don't breathe. They don't reproduce the way cells do. They simply convert. One normal protein touches the wrong shape and becomes it. No DNA, no life. Still contagious. Number 5. The cosmic microwave background, noise. In 1964, scientists detected a sound that wouldn't go away. It wasn't music. It wasn't a signal. It wasn't even intentional. It was static. 2 radio astronomers, Arno Penzias and Robert Wilson, were testing a large microwave antenna in New Jersey. No matter where they pointed it, day or night, city or sky, there was a faint, persistent hiss in the background. They checked everything. Faulty wiring, electronic interference, even pigeon droppings inside the antenna. The noise remained. It came from every direction in space. What they were hearing wasn't interference. It was ancient. Across town, another group of physicists had predicted something remarkable. If the universe began in a hot, dense state, there should still be a faint thermal glow left over, stretched and cooled as space expanded. When the 2 teams compared notes, the static suddenly had meaning. The hiss was the cosmic microwave background radiation, the leftover heat from the Big Bang itself. Light that had been traveling for nearly 14 billion years. Not a signal sent deliberately. An afterglow. The discovery confirmed that the universe had a beginning, a hot, explosive origin that expanded over time. It wasn't eternal and unchanging. It had a starting point. The unsettling part. Every time you tune an old analog television to an empty channel and see faint static, a tiny fraction of that noise is the same cosmic background. A whisper from the birth of the universe. Scientists thought it was equipment error. It was the echo of the beginning. Number 4. The Antikythera mechanism. In 1901, divers pulled a corroded lump of bronze from a Roman shipwreck off the coast of Greece. At first, it looked like debris. Then they cleaned it. Inside were gears. Dozens of them. Precise, interlocking bronze gears carved more than 2,000 years ago. The object became known as the Antikythera mechanism. and it stunned historians. Nothing that mechanically complex was believed to exist in the ancient world. Comparable clockwork technology wouldn't appear again in Europe for over 1,000 years. But this device was real. Careful analysis revealed that it was an astronomical calculator. By turning a crank, it could predict solar eclipses, lunar cycles, planetary positions, and even Olympic Games dates. It modeled the motions of celestial bodies using intricate gear ratios that required advanced mathematical understanding. This wasn't decoration. It was engineering. The mechanism suggested that ancient Greek scientists had reached a level of mechanical sophistication far beyond what textbooks once credited them with. It hinted at a lost tradition of complex machinery, knowledge that may have disappeared after political collapse and war. For decades, scholars struggled to explain how such precision could exist in the 1st century BCE. X-ray imaging later revealed even more detailed inscriptions and layered gears hidden inside the fragments. The unsettling part isn't that ancient people were intelligent. It's that entire technological capabilities can vanish. Civilizations rise. Knowledge advances. Then it gets lost. The Antikythera mechanism wasn't impossible. It was simply ahead of its time, and history forgot how to build it. Number 3. Dark matter. Galaxies are spinning too fast. According to physics, they should fly apart. When astronomers measured how quickly stars orbit the centers of galaxies, the numbers didn't make sense. The visible matter, stars, gas, dust, wasn't enough to provide the gravitational pull needed to hold everything together. By all calculations, galaxies should have torn themselves apart long ago, but they didn't. Whoa, something unseen was adding extra gravity, something massive. This missing mass became known as dark matter. It doesn't emit light, it doesn't reflect light, it doesn't absorb light, it's invisible. Yet its gravitational effects are measurable. Galaxies rotate as if surrounded by enormous halos of hidden mass. Clusters of galaxies bend light passing behind them, an effect called gravitational lensing, revealing far more mass than we can see. Current estimates suggest that ordinary matter, everything we can touch and observe, makes up only about 5% of the universe. Dark matter accounts for roughly 27%. The rest is something even stranger: dark energy. The unsettling part? Most of reality is invisible. Every star, planet, and human being exists inside a vast framework of something we cannot directly detect. Scientists don't yet know what dark matter is made of. It doesn't behave like normal atoms. It doesn't interact with light. It simply exerts gravity. The universe isn't mostly stars. It's mostly unseen structure holding those stars in place. Galaxies spin because something is there. We just can't see it. Number 2. Barry Marshall drinking bacteria. In the 1980s, stomach ulcers were blamed on stress, spicy food, anxiety, lifestyle. Doctors were certain. Then an Australian physician named Barry Marshall proposed something radical. Ulcers were caused by bacteria, specifically a spiral-shaped bacterium called Helicobacter pylori, living in the stomach lining. The idea sounded impossible. The stomach was believed to be too acidic for bacteria to survive. The medical community dismissed the claim. But so Marshall did something extreme. He drank a flask filled with the bacteria. Within days, he developed severe stomach inflammation, nausea, pain. Biopsies confirmed the infection. The bacteria had colonized his stomach exactly as he predicted. He then treated himself with antibiotics, and the symptoms disappeared. It was direct, undeniable proof. Ulcers were not primarily caused by stress. They were often the result of bacterial infection. The discovery completely transformed treatment. Instead of long-term acid suppression, patients could be cured with antibiotics. Millions of people worldwide benefited. At first, his work struggled for acceptance. It challenged decades of established medical belief. But evidence accumulated. Studies replicated the findings. In 2005, Barry Marshall and Robin Warren received the Nobel Prize in Physiology or Medicine. The unsettling part: a major disease affecting millions had been misunderstood for years. Not because the bacteria were invisible, but because the assumption was strong. Sometimes a discovery isn't ignored because it lacks evidence. It's ignored because it disrupts certainty. And sometimes proving the truth means swallowing it. Number 1. The wow signal. In 1977, a radio telescope picked up something it was never supposed to hear. A powerful, narrowband signal from deep space. It lasted 72 seconds. Then it vanished. The signal was detected by Ohio State University's Big Ear radio telescope during a search for extraterrestrial transmissions. When astronomer Jerry Amon reviewed the data printout, he circled the unusual sequence of characters and wrote one word beside it. Wow! The signal was extraordinarily strong compared to background noise. It came from the direction of the constellation Sagittarius. It matched the frequency hydrogen emits, a frequency many scientists believe intelligent civilizations might use to broadcast across space. It wasn't random static, it had structure, and then it was gone. Astronomers searched the same region again and again. Nothing. No repeat. No confirmation. No clear natural explanation. Over the years, theories have ranged from comets to satellite interference to unknown cosmic phenomena. None fully account for its strength and precision. The unsettling part isn't that it might have been aliens, it's that we don't know. In a universe billions of light years wide, a single unexplained signal appeared, perfectly timed, perfectly placed, and then never spoke again. No follow-up, no pattern, just silence. It wasn't proven to be intelligent. It wasn't proven to be natural. It was simply real. A brief whisper from the dark. And then the universe went quiet again.